Welcome everyone to another Directions Mag Geospatial webinar, today sponsored by Esri. I'm Barbary Duke, Managing Editor here at Directions Magazine, joined by our assistant webinar producer, Lynette Qualia. So we are welcoming back the talented team of Shannon Kaliski, Alberto Nito, and Lipika Gimler. We're excited to take ArcGIS Notebooks to the next level. This is a continuation of what they talked about previously. And so without further ado, over to you, Lipika.
Hello, everyone. My name is Lipika Gimler, and I am the product marketer for Esri Spatial Data Science products. And joining me today is Shannon Kaliski, product manager for Esri's Spatial Data Science products, and Alberto Nieto, product engineer on the spatial statistics team here at Esri. We're excited for our session with you today, wherein we will be diving deep into some of the most exciting capabilities of ArcGIS Notebooks, specifically around using GIS and Jupyter for workflow automation. Before we get started, a quick overview of our agenda today. We'll be kicking it off with a brief introduction of some essential concepts around ArcGIS Notebooks and the ArcGIS Python libraries, followed by some demos on data exploration and data engineering, a run-through of applied analytics, and followed by some more demos and how-tos. We have a pretty packed day for you today. During the session, we will also be opening up some polling questions to you, our audience, so that we may better understand the workflows that you're involved in and the types of problems that you are seeking to solve. And with that, I'd like to open up to our very first poll question to you. What types of workflows would you be interested in automating with Python? And you can select all of that apply to you. Do you intend on using Python for automating administrative activities, such as managing content or managing users, for data cleanup, for analysis tasks, or for creating information products, such as dashboards and web apps? We'll leave it up here for a few more seconds to get some responses in. And there are our results. So great news. Since you have the analytics team with you, this is going to be the perfect session, given that analysis tasks are taking up 80% of your automation needs, followed by data cleanup, creating information products, and lastly, administrative activities. Thank you for your responses. And with that, I'll hand it back to Shannon to get us started for the day.
Thanks, Lipika. Just really quick, hi everyone, I'm Shannon. Alberto, how about you say hi? Because I will probably talk to you sometime when I'm going through these slides, and I don't want people to be like, who is this stranger talking to us all of a sudden?
Yeah, absolutely. Hi everyone, my name is Alberto Nieto. It's great to have you here. Thank you for joining us, and I will definitely be chiming in. I hope you're doing well.
Yes, it's a crazy time, but today we're talking about automation. So easy question up front, why do we automate? Well, one, we want to do repetitive things faster. And this can be everything from updating maybe some raw data to hydrating in deliverables. Maybe that's a dashboard, maybe it's a map, maybe it's some other kind of app, to cleaning up our data, because I've met exactly one person who really loved cleaning data. Like that was just their favorite thing, was just cleaning data. But for most of us, if we could make that part of the job go a little faster, that would be great. Generating raw data, we'll actually see a demo a little bit later where I use deep learning to generate some raw data and see how that can walk us through some automation. Scenario testing. So imagine for a lot of the workflows that you can automate, of course, you can do them manually. Almost all of them, you would have this option. Some things in the machine deep learning space, it would be much more challenging to do it manually, very time consuming. But when it comes into the world of scenario testing, automation can be super helpful, because it's not just, hey, I'm going to do this once and get some results. It's somebody wants to change not only the data that's going in, but maybe some of the parameters that you're setting. And to be able to streamline that so you're not walking back through, stitching a workflow. If you were like me when I was a GIS analyst, you had way too much mess in your GP history. So it wasn't as simple as just, oh, let me see what I did and rerun that. We've all been there. And also if you're doing administrative work, a lot of us as GIS folk or spatial data scientists wear multiple hats. We aren't just the person doing the analysis, cleaning and prepping the data, we also are oftentimes the one managing the entire GIS for the organization. And all of those hats must be worn and jobs be done in the same business day. So if we can automate that part of the job, it can help free us up for the things that we really enjoy doing. Another thing is to reduce errors. I'm from Texas, which has over 200 counties. If I had to do a manual workflow, such as generating a report based on some spatial information for every single county, odds are somewhere in that process, I'm going to start making some mistakes just from fatigue, spacing out. There'll be maybe a typo, or maybe I didn't update a data pointing to the right source. And so automation can help us keep that on track. And then there's also the idea of documentation and transparency, being able to show people what we're doing, how we did it, and be able to create these really reproducible workflows. And I think one thing that's really timely for us is how the whole geospatial community came together around COVID-19. This was a time, and it still is, where we have global time-sensitive data that's changing every day. Now, luckily, a lot of places are starting to move towards looking to reopen again, but we can all remember the very beginning of this pandemic, where there was just this mad rush for information. And for a lot of GIS teams around the world, it meant figuring out how to start building automated workflows on the fly where they didn't exist before. And overall, as a community, despite some struggles we may have had along the way, I think we did an amazing job. We were able to put out dashboards, data, and information products that could help inform decision makers and just the general public in a time where it was scary and new, and we all wanted to know where we could get toilet paper and hand sanitizer. So not to make light of it, but we've all been probably socially distancing and working from home for a while, so it's kind of good to laugh at it in a way. But the focus of this webinar today is really going to be about how do we automate, and there's lots of ways to do it. I mean, you could write regular Python scripts, you could do workflows in R, you could use graphical interfaces to build models. So in ArcGIS, we have model builder, we have raster functions, we have in ArcGIS Velocity, which is our IoT kind of product for real-time and big data analysis. They have a graphical model builder for being able to put workflows together. There's lots of options out there, and none of them are wrong. I mean, whatever is working for you is good. But what we're going to focus on today is actually ArcGIS Notebooks. Now, when I think of ArcGIS Notebooks, I think of it as being the spatial notebook. Notebooks coming, of course, from the fact that there's tons of Python notebooks out there. There's Jupyter, which is kind of the OG of the notebooks world, but there's also you can find notebooks everywhere. I think in my last look on GitHub, they were almost at 10 million publicly shared Jupyter notebooks, which is crazy that is how many are out there. But just to break it down a little more, the reason I call out that it's the spatial notebook, not just a notebook, is because there are so many notebooks. And a lot of notebooks you can fit some spatial data into, but you don't have that access to readily available spatial data sets, to all of the algorithms that come included through the ArcGIS Python libraries, which we're going to talk about in here just a second. So there's this long tradition of spatial data science at Esri, and for everyone interested in analysis, that can be really helpful because it's not about trying to fit spatial data into a non-spatial method. It's really about honoring the things that make spatial data different and also better, so we can build effective models that are taking into account things like proximity, distance, area, whatever it is that can actually help us perhaps reduce the dimensionality of models that we're building, but also just contextualize and explain the problems that we're trying to solve. And what we'll see in my first demo that will come up here in a little bit is that ArcGIS Notebooks has this optimized interface. It's built into ArcGIS, it's really integrated, and it makes it easy to work with, whether you're someone who's newer to getting started with Python, or if you're someone that says, I don't need the bells and whistles, I just want to get down to some straight up coding. And then, of course, it's built on Jupyter, which is, because it's so popular, means there's tons of resources out there. And added benefit is if you are someone who already has Jupyter Notebooks, so you have IPy and B files, that's the name of the file extension, you can just bring those in. You don't have to start from scratch. So you can start with the work that you already have. And what I like about notebooks is that it sits at this nice intersection of ArcGIS and then open source. So all of the open source Python packages and data science libraries that are key to the data science community and spatial data science as a whole. It's not about choosing one or the other. It's really about making the best of both of them. And we include over 300 Python packages ready to use within ArcGIS Notebooks, meaning that you don't have to do a pip install, you don't have to do a conda install, you don't have to go and manage any dependencies. They're just there ready for you to use. And some of these packages include the ArcGIS Python library. So these are the libraries that you may know Esri for, ArcPy being the longest standing of the two. And then the ArcGIS API for Python, which is really simple and lightweight, works with a lot of web GIS. But both of these complement each other. I get the question all the time, Alberto, I'm sure you do too, which is, what is the difference? Like, is one going to eat the other? What's happening with this? And the answer is no, one is not eating the other. They're both really useful. They do similar things. This is true. But it's no longer this world of, oh, well, ArcPy is just for the desktop and Python API, that's just for the web. No, no, no. With notebooks, we have put them all over the place. Python API is now in Pro. ArcPy is now in Online and Enterprise, and you can just straight up code against it, which is really nice. One of the reasons I say that they're not going to consume each other is both of them are quite massive. So the work of consuming each other would be impractical. And plus, they have their own strengths. So ArcPy, for example, has over 1,300. Actually, it's more than that. It's 1,700. My edit didn't save. I mean, it's still true. It is more than 1,300, but it's actually 1,718 tools in Pro26, if you needed that exact trivia for any purpose today.
Everyone should know that number by memory.
Just so you have it, yes. And there's lots of different things you can do. This is obviously just a sampling, and I don't expect people to read all of this, but just to think about how each tool has different methods and functions within that unlock possibilities for us to do spatial machine learning, for us to do spatial statistics. That's Alberto's favorite, because that's the team he's on. But also powerful ways of managing data and doing transformation, honoring spatial projections, all of those things that to the non-geospatial community, they may write off and say, what's the big deal? But we know that there's a big difference between if you're using let's say a Mercator projection or an equal Earth projection, and that can make a difference between how people interpret your results and how they make decisions. So ArcPy is really powerful for that. And then we have the Python API that is a younger API. It came out, I would say, 3 or 4 years ago. It has grown really fast in a short period of time, has over 2,300 methods and functions. You can see some of them here, but again, not a comprehensive list. And the part of the strength of the Python API is really starting to bring in things like the data frames that you're used to working with in Pandas, or making it simple to approach deep learning. So instead of writing lines and lines of TensorFlow, you are just writing about 3 lines of code in the Python API, and you're able to build an effective deep learning model. And that can be something especially useful if you're someone just getting started. But it's not just us. If you're a geospatial person, you also are probably aware of some of the FOSS4G libraries, those open source geospatial libraries. And with a lot of things in ArcGIS, we not only want to work with this, it's not about choosing, but we've also made it easier. So for example, in the spatially enabled data frame in ArcGIS, GeoPandas is now, you can just read GeoPandas in, which makes it really convenient because it's not about transforming data anymore. It's just about getting to work. We're also in the approval process of having the spatially enabled data frame be input to PySal. So that would mean that you don't have to take your spatially enabled data frame, turn it into something else before you go into, an analysis library like PySal, which would be really effective. And those are just ways that we continue to reach out through the open source community, through our own tools, and try to do more. Now, before I get to my demo, just so you know, how do you access these? Well, like I said at the beginning, it's probably already included. We have over 300 there. We add more every release. We have an online resource that provides a list of every package and the exact version that we include. And if it's not included, no need to panic. You can still do a pip or conda install if you're working kind of on the fly there. If you're working in Pro, you also can persist those, so you're not having to always do pip and conda installs by simply modifying your Pro's Python environment. Or if you're working in a server, so if you're working with ArcGIS Enterprise, also great options for creating customizations. You can customize the entire Docker runtime. So that way, everyone in your organization is working from that same customization. So if you have special libraries or Python packages that you have created or want to use, you can make sure that everyone has equal access, which really helps with that reproducibility and transparency. But with that, Alberto and I are going to dive in to some demos. So I'm going to kick us off. We're going to go to Hawaii. I know we all wish we could just go to Hawaii right now. It looks beautiful. I've never been. And then Alberto is going to talk to us about something, you know, quite timely right now, voter turnout. We do hope everyone votes. Okay, let's go into a notebook. Now here I am in ArcGIS Notebooks. I'll rerun this first cell just to make sure everything's nice and fresh. If you caught that little pink Jupyter message that I had at the beginning, all that was telling me is that I'm an administrator. It only shows up the first time you run a cell. And the reason we let admins know that you are an administrator is just so A, you don't forget, and B, Python's really powerful. So if you are running a notebook as an admin, you don't want to be doing something that you are not sure of. Reduce your privileges, switch to a different role if you're just testing something out. And please never, ever go find a random notebook off the street, bring it in, and just run all cells blindly. No, know what's in these things. But for those that are new to Jupyter and have never seen one before, this kind of body area that I'm looking at here, it looks just like a regular Jupyter notebook. So if you are familiar, you're like, yeah, it does. So what's the big deal? Okay, so the big deal is where it comes into some of the ways we've integrated content in. So I can search for my own content. I can search for content throughout my organization, and I can search for content in the Living Atlas, including 3D content. So for example, I can bring in this web scene of Rotterdam. You'll notice it created an automatic Python snippet for me. All I have to do is change that to whatever name I want. It's Rotterdam, so I'll give it an R, so I'm quite creative. And then if I click on this, it can take me to that item's details page. But who wants to just look at, you know, a little thumbnail chiclet sort of thing? We want to actually do the work with the analysis. So I'm going to go ahead and, oops, not an import, call the Python API because it's ready to work with. So from our features module, we're going to import web scene because this is a 3D web scene. Oops, from ArcGIS web scene, ArcGIS.features. Did I spell that? Oh. Some mapping. There we go. It always helps to get the right module. There's a lot of them, as we just covered on that last slide. Okay, so now that we have that, all we need to do is create a web scene, and then web scene is one of the easiest Python snippets ever. And what that's going to do is bring up our map widget. You can see it's already in 3 dimensions. It's going to navigate me to the right part of the world, flip it so that I can see all of this lovely things in Rotterdam. And it's not just some still image that I can look at. I can actually pan around. I can tilt it. I can do whatever I want. So we're not limited to 2D data in map widgets. I just wanted to show that. But when it comes to exploration, because this was a data exploration demo, and I said we were going to Hawaii, and everyone was excited, we can go and search content. So for example, I'm going to go to some Hawaii Trails data. State of Hawaii GIS sounds pretty authoritative to me, so I'll go ahead and go with their data. We'll just leave it as item right now. This would bring me to that item's details page. And then we can start doing some simple exploration through working with Pandas data frame. So here I'm going to bring in some more Python modules. So this time we're going to use features. And we're going to import Pandas as well. And my favorite charting library, just for giggles. I like Seaborn because it's really easy, especially if you're a beginner. You can do some really quick stuff really simply. So let's go ahead and we're going to create a data frame. So Alberto is going to be diving into this also, but I just wanted to show you some of the basics. So this is using, it's built on Pandas, so that means that we can also use libraries that work with Pandas to work with this. So we'll give it an index of 0. And calling head just brings us back the first 5 rows. So you can see here's, remember we start with 0, so there's 5 there. And so we can look at that data there. And if we wanted to see kind of something, how that data is distributed, I brought in Seaborn because I said it was easy and I wasn't lying to you. If we wanted to look at something like, what does the street access look like for this data? We just tell it what data frame we're looking at. We named our data frame SDF. And then we can see that we have mostly 2-wheel drive, some trails in Hawaii that are going to require 4-wheel drive, some that we can only get to by foot, and some unknown. So this is some mess we might want to clean up. And then if we wanted to visualize this data in a map, for example, we could absolutely do that just by simply calling gis.map. We're in Hawaii. There's a built-in geocoder, so all I have to do is write the name of the place I want to go. So I'm going to tell it Hawaii, add layer, and then we're going to call it that item, call our map, and then we're going to get a nice 2D map, brings us to Hawaii. Hawaii is kind of spread out, so we got to zoom in a little bit. And then we see those on the map right there. Now, that was really kind of a short little look at how do we visualize some data. A couple other things before I turn it over to Alberto. There are analysis tools in here ready to go. I'm going to show some of these later. You can see they insert Python snippets just waiting for parameters for us to put in. You also have access to your own private workspace. So if you wanted to bring in CV data, PNG, you were working with ArcPy and you wanted to be able to use that here, this is where you would create your file geodatabases and start building those. Sharing is straightforward. You can go and share workflows. And a little later, I'll show you scheduling. This is actually a 10.8 build, and at 10.8.1, we added scheduling. But I'm going to save that for a little later. One last thing, let me just save this before we go. Samples. If you are someone who's just getting started and you are thinking, this is great, you made that look easy, but I don't know what exactly I want to do or how to start, we have samples for everything from administration. You can see some things here like deploying automatic notifications or managing inactive users. These are all ready for you to start working with. Some of them you need to enter information. So for example, if it's something that's managing a group, you need to tell it what group you want because right now it's just kind of set generically. But we also have analysis and data science workflows that cover everything from some basic exploration to getting into deep learning, machine learning, even things like forest-based classification and regression from ArcPy. So lots of cool stuff there for you to check out as well. But I'm going to turn it over to Alberto.
Awesome. Thank you so much. So let me share my screen. Great. I just keep thinking of that statistic you cited, Shannon, about how many notebooks there are out in the world, and I wonder how many of them are named Untitled or Test. It would be so curious to learn about that. So in any case, we're going to create some more notebooks here. And the example we're dealing with, we don't get the pleasure of traveling to Hawaii or even Rotterdam. We're going to stay here in the United States where we're dealing with quite a few problems. One of those is voter participation, right? We have obviously an upcoming presidential election. And participating in this process, I think, is quite important. So there's a lot of analyses that can be done around this concept of participating in an election. And most examples that even we show are kind of these perfectly curated data sets that are just ready to hop right into the geoprocessing analysis tool, and it's all shiny and perfect world. But as Shannon mentioned, most of the work typically happens in the data preparation or data cleanup side of the house, right? There's several statistics that people cite about how much cleanup has to happen, how much of the time that takes, like on the orders of 3/4 of your time is spent just cleaning data. And my challenge today is not just to touch on a sensitive subject, but also to make a data cleanup demonstration exciting for you. So hopefully by the end of this, you're super excited. So the example that we're going to get into is voter participation. In this case, we're looking at the final data set that we're going to get to, which is voter turnout per county. Some quick statistics that you'll be able to assess is which states are doing better in voter turnout. We're looking at 2016 results. So Colorado, New Hampshire, Minnesota, those were the states that performed pretty well in terms of how many people participated as a proportion of the voting age population, whereas West Virginia, Tennessee, Arkansas, those are examples of some of the states where voter participation tends to be pretty low. And once you have this data set nicely curated, you can do data visualization, or you may pop it into a predictive model if you're trying to assess what participation may be like in a few months. But as I said, I really want to change gears and show you the gritty details of cleaning up this data before we get to this point. So what we're going to do is we're going to start with a basic template of just counties without that voter turnout data. And I want to take you through an example of a notebook where we're going to do this. And a few caveats. I don't expect you to remember every line of code that I'll show you. That's not really possible. It's too much, frankly, but my goal is to share this notebook with you, introduce the concepts through this recording or through this video. And the next time you look at this notebook and hopefully rewatch the recording if you're interested, now the concepts will start to make sense. Some of you may already know all of this, and this is just simply another example. So I'm going to simplify it. And as Shannon mentioned, the notebook, the format really is conducive to prototyping because it works with these cells, right? So I have a lot of narrative here just explaining what we're about to do. Really, it's all summarized into 3 steps. Even though it gets a little complex, we're just going to basically load, clean, and prepare election data in step 1. Then we're going to geo-enable it. Then we're going to geo-enrich it. So step 1, I also have these breakouts. I really suggest, as a quick tip, if you work with notebooks, really make use of Markdown. Markdown helps you organize your text and helps you build a narrative that if a poor fellow analyst or data engineer needs to see your notebook, hopefully they're able to read through it rather than just guess at what you were thinking that day when you channeled all this Python into action, right? So the first thing we're going to do is some basic importing of needed modules. As Shannon mentioned, we can bring in quite a few modules. ArcGIS and ArcPy are both tools I need. I don't need to choose from one or the other. I'm simply going to choose both because they both have some things I can use for different purposes. Also pandas, Shannon mentioned the data frame. I'm going to assign some homework. You didn't know you were going to get homework here, but if you know Python but you don't know pandas, that's your homework. Learn some pandas. It's really, really powerful if you're working with data. So the first things that we're going to do here is we're going to make reference to our ArcGIS Pro project. So we're looking at a notebook inside ArcGIS Pro, which is really well integrated, and I think it's conducive to doing this type of data prep. And I'm making reference to our current Pro project so that we can load some data or run geoprocessing analysis tools here. We're making reference to the file geodatabase. If you're familiar with ArcPy, these are some commands that you may be used to seeing in the past. And then more importantly, we're going to load the data. So here's what the data looks like. We're reading a CSV of the county presidential election turnout, or the amount of votes basically by county for several elections in the past. And the table looks like this. So some operations that we may want to do, we can start with simple stuff like just handling missing data. Several counties may have null records for total votes or for FIPS code. And that's kind of like the first baby steps you may take into doing some data engineering. So what I really like about Python is you can kind of really just customize it to do what you want it to do. For instance, what I wanted to do is to tell me how many records have null FIPS values. And FIPS is basically the unique identifier for each county. And I also wanted to tell me the percentage of the data that that corresponds to so that I can make an assessment. Do I need to worry about that missing value? So for FIPS, only about 0.13% of the available data has null FIPS, amounts to 64 records. So basically, I'm just going to trim those out. I don't need those records. And the next cell basically trims them out. If I go up here and hit run again, now we see that that operation succeeded. Now we have no longer any records with null FIPS values. Alternatively, we may want to just tweak that cell of code, and let's say that we want to check on the candidate votes field. So I'm going to copy that, paste it here, plop that there, and now we can just rerun that cell and make an assessment for a different field. So pretty easy, just copy, paste, and rerun the Python code that you already wrote for a different purpose. So for candidate votes, it's a little bit more, but still very few records, so I could choose to remove those if I wanted to. The next example is something that a lot of GIS folks run into, especially when you're working with counties or any type of administrative boundary, perhaps internationally too. These IDs come as numeric values because they are numbers, but generally many counties have leading zeros. So if you interpret it numerically, these leading zeros get truncated. So that's a common headache for many data engineers to worry about. So what we're going to do here is basically create a quick little utility to help us address that. So we can see some of the Alabama counties have leading zeros that are truncated, and we got to deal with that. And the utility basically is going to be a helper function called fix truncated zeros. We're going to write it here, and then we're going to test it right underneath it. Basically, I'm going to pass a value called 1121 to fix truncated zeros. Let's see what it does. It gives us a 01121, and just like that, we can also test it with, let's say, 91121, re-execute it. It should leave it alone. We don't want it to append a 0 to this 5-character FIPS code. So it looks like it's working. Now we can go ahead and apply it and see if it worked. And now our Alabama counties have a leading 0 appended to them. Nice and gravy. Now we're going to get into something a little bit more interesting, and we are going to get a little faster just to cover everything. So this is a little bit more interesting. We're going to reformat the table structure to help us do some analysis. Essentially what we have going on here is, if you look at this table up here, we have records. We have several records for each county, for each candidate, essentially, and the amount of votes that they got. And what we need is each record to correspond to each county individually, and the fields then to contain the different candidates and the different amounts of votes that they received. So if you look at this animation, this is going to highlight what we need to do. We need to take the county FIPS, remove the duplicates, then pivot the rest of the fields so that they become, or the rest of the entries so that they become fields, and then append some qualifiers to the fields so that we can tell the fields apart for the candidate Democrat, candidate Republican, candidate other, and the amount of votes that each one got. And then there's our restructured table. So it's a little bit complex. Again, if you don't follow one-to-one, don't worry. Just use this notebook at your own pace and hopefully learn from it. And believe it or not, all of that is done through this cell. So pandas and Python are, I think, the rise in popularity is because of their ability to handle things like this. I know other languages already do that. R and data frames have been an inspiration to Python. But for those of us that have chosen Python as our main language, it's great to be able to do an operation like that pretty straightforward and be able to automate it, right? So here's our restructured table. Again, that's a lot of code. So what I like about notebooks is that, let's say you're using them for educational purposes, you can break that down step by step and really fully understand it. Let's say you're using this notebook to teach a class. Right here, I break it down basically to each subset step and really try to explain what that operation did to restructure our data. So I'm just going to execute these cells and get to our next step for the sake of time. One more thing that we may want to do is engineer some new fields, right? So all we have right now is how many votes happen for each candidate for each party. But what we may want to do is basically create the voter share per party, meaning like the amount of votes that went to, of the total votes as a percentage that went to each party, or the raw differences or percent differences between the major parties. Those will make pretty interesting maps. So here in Python and through data frames, you can make those calculations wholesale for the field pretty quickly. And that's really sort of the power of pandas in conjunction with ArcGIS. So we have this nice table now, restructured, cleaned up. We have a lot of fields that eventually will make really interesting maps and hopefully useful maps. And now we're ready to geo-enable it. Essentially what we're doing here is making it available for use within GIS. Because all we're looking at is a tabular data set. It's a table in memory. So this is where the ArcGIS API for Python comes in. I'm basically authenticating with a GIS, searching the living atlas for a county's data set to give me some geometry. Originally, I was going to just use counties generalized, but I noticed that we needed the amount of people in each county that can vote as a denominator in voter turnout. So Living Atlas actually happened to have that available. So that's kind of another neat thing about using this in ArcGIS. You get access to a lot of data wholesale. And now we can bring that in as a pandas, or basically a spatially enabled data frame, which Shannon briefly introduced you to. And that's going to be kind of the backbone to our data. That's going to be the geometry, all the shapes of all the counties, and then to that backbone, we're going to bring all the additional fields that we just engineered from the election tables. So here's our backbone table. Now we're going to join it. The way we join it is with a pd.merge. Again, if you don't track fully all this code, the goal is just to introduce you to the concepts, show you the high-level concepts, and then at your own time, you look at this code and take it one step at a time. So now we have this GeoDF spatially enabled data frame. It's beautiful for our purposes. Basically, we have all the data we want, and then right here at the end, we have our geometry, which is the shape field. So at this point, we're basically just about ready to start working with it in GIS. And I'm going to essentially just query for 1 year, 2016. I don't want to work with the entire history of data yet. We could. And I'm going to dock this to the right just so that we take a look at the map. I'm going to expand my contents, table of contents, so that we can see the legend when it's produced. And I'm going to convert this data frame to a feature class. And that's a pretty basic operation right here. Basically, we're just going to use the spatially enabled data frame to feature class method, which is one of my favorite functions just because we do a lot of conversion from Python data frames to GIS and back and forth. So this, after a few seconds, will give us essentially the process data. Now, I already know there is one issue that's going to come back. If you just use Python alone and just notebooks, you typically wouldn't see this issue that's coming up, but there is one county that's missing data. And let's see, drum roll, please. We're about to get the counties. Yep, there it is. And the issue is glaring. It's basically a missing county hole in our data set. If I select that, the county is called Oglala Lakota County. It's in South Dakota. And a little bit of research, as any data engineer would have to do, would suggest that basically this county was a mess and not really just for the purposes of naming conventions and FIPS codes. It changed name and FIPS code a few years back in 2015. It changed from
Excellent
Shannon
choice of name
County.
change.
Yeah, I don't know why they would rename Shannon County to Oglala Lakota. But it does give us a headache here because now we're missing that county from our output and we need to figure out what happened. So one quick thing I'm going to end with here for this demo. If we need to fix something like this, something that you can do is just snap on a little bit of processing to your notebook, right? So I'm going to scroll back up to where we had our final data frame before we brought geometry. I'm going to create a cell here. Once again, I'm a big fan of Markdown, so I'm going to change it to just be a narrative. I'm going to title it, Fix the Shannon County Mess. Let's put an exclamation mark. And then for this county, let's assess what's going on here. So I'm going to locate for where the FIPS code equals. And if we look back at our little web page, it's supposed to be 46102. That's what it is currently, and the name is Oglala Lakota. So let's check for 46102. Okay, no counties came back. I'm going to copy and paste the cell. Let's check for the old FIPS, which is 46113. That's what it used to be a few years back. And we do see that that's the problem. It has the old FIPS, but the new name. So it's a weird matchup, and it's likely because this data set is used for historical analysis. So what we're going to do is right here, we're going to correct this. And the way we can correct it, because we're working in a notebook, it's really easy to just copy paste code and just append to it. So what I'm going to do is for the records that come back from this query, which we see up here, we're going to say for the FIPS field, now give it the value 46102. And now if I copy paste this below it and re-execute it. Now we don't see any counties with 46113, but if I check for 46102, we have the data, those records corrected, right FIPS, right name, everything's much better. We've fixed the Shannon County mess. And now to finish the full process, all we need to do is re-execute the cells where we merged it with our backbone geometry table and brought the data frame to a feature class. So let's do it one more time. I'm gonna reprocess this. And now after a few more seconds, now the true drum roll happens. We should get that data set basically with the full county allotment and that hole filled in, because the FIPS code now should match what we're seeing in the Living Atlas. While this is processing, I do want to make a quick note. Step 3 I'm not going to cover, but really this is about bringing additional data for each county to each to analyze in conjunction with voter participation. And while you can do that from a Python notebook and from ArcGIS Notebooks, it's certainly something you could do. By the way, here's the fully enabled data set with the hole filled in, so we've done our job. But what I was saying here is there are GUI utilities, both in ArcGIS Pro or ArcGIS Online or Enterprise, really, where we can utilize just the right tool. And in some cases, a GUI may just be fine for evaluating what type of geo-enrichment data we might want to use. So if I want to bring in ages or income or things like that, something that you would likely want to do instead of trying to browse through that in Python, especially if you don't know how that works, is use the enrich tool and the GUI that comes with it to just evaluate what variables you would want to bring to analyze in conjunction with voter turnout. So that data set is now ready. If I change the symbology, we would get back to what we had here, where we're evaluating voter turnout. That's my demonstration. I'm going to hand it back to Shannon.
Thanks, Alberto. I'm pretty sure Shannon County mess was probably, fix Shannon County mess was probably on some to-do list, like when I was a GIS intern, and we're just like, fix that mess you just made. Okay, so just really quickly, how is ArcGIS Notebooks different than Jupyter? Well, it's built within ArcGIS rather than sitting beside it. So I showed you it in the hosted space, which would be the experience you would see if you were using online or enterprise. And then Alberto showed you it within Pro. So it was nice that it's all built in. We didn't have to go back and forth. It was really great. You saw an integrated UI. We get this a lot in the hosted space with the ability to add automatic Python snippets, but in the Pro space, you get it with the ability to seamlessly connect to what's in your table of contents and have things automatically write to your table of contents, as we saw from Alberto. If you're working in online or enterprise, your notebooks are items, meaning that if you back up your portal, there they are. If you can access your WebGIS, you can access your notebooks in your environment. And if you're working in Pro, your notebooks are just built into your Pro project. So you don't have to manage them separately or wonder where they are. Pro is keeping track of that for you. And if you're someone that says, you know, maybe you teach, or maybe you have a lot of Mac users in your organization, or you work with data scientists who aren't going to pick up Pro, but you still want them to have the power of ArcPy, using notebooks in online or enterprise gives you the access to ArcPy, but doesn't require you to have Pro. But as you saw from Alberto, there's lots of benefits to using notebooks in Pro as well, if that's your interface. It's really a powerful spatial data science workstation. And of course, you can centrally manage your libraries and packages. But enough with that. Let us keep going to, come on, slide, catch up. Come on. Oh, it's loading. It's loading. I'm going to start telling you about what's on it. Okay, there we go. Too fast. We're going to get to those demos. But so now we're going to get into analysis. We don't need to stop at those building blocks. I'll tell you the building blocks. It's, the slide reloaded. Engineering, visualization, you saw that in those first few demos. In the next 2 demos, you're going to see the next 3. Modeling and scripting is what we've been talking about all day. And sharing and collaboration is a much bigger story, but of course you can do that just through a notebook as well. But for the sake of time, let's get to the demos. 80% of you wanted to automate analysis workflows. So Alberto, back to you. Let's take a look at some police data from the Philly area.
Great. This will be really, really fast because I took a little bit more time for the first demonstration. So
it was a wonderful demonstration.
I appreciate it. So once again, we're going to go back to ArcGIS Pro. The idea here is that we're looking at an analysis related to stop and frisk locations in Philadelphia. Very often, we do these analyses that focus on crime and burglaries or theft, but certainly recently there's been a bigger focus on understanding police activity and whether things need to change in any way there. And what we were looking at is basically trying to understand the patterns of stop and frisk and whether they are co-located with crime, whether stop and frisk tends to occur near or in the vicinity, both in space and time, with crime. In this example, I'm not going to go through it in detail again because I consumed more than my time in the first demo, but I can share this work. And the idea here is, once again, we're going to prepare some data ahead of doing some analysis. So the inputs would be two tables. One table is basically the table of stops or stop and frisk, and the other table would be the stops of incidents, and they come from different locations. So what's kind of neat about Python is that if those sources change, you can simply have the notebook read directly from the source. Additionally, as we did before, we can handle some missing data. So I literally just copied and pasted from the cells I used for the voter turnout example and applied them here. You probably get pretty familiar if you do a lot of Python coding that you have your favorite Python snippets, or maybe you build your own Python libraries, and you can kind of keep leveraging them. The idea here, though, is that we want to assess the comparisons of stops and crime, not just in location, but in time. So there's a few new utilities. This utility compares the extent and time between stops and crime. There is a mismatch. We have a lot more data for stops, a lot less data for crime, just 1 year. So there's a little bit of a utility here that just trims the stops data set to be basically coincident with the crime data. And over here, what we're going to try to do, I'm going to skip a little bit of this and just get to the charts, because the charts are kind of what start getting into the analysis. So we can create these ArcGIS charts within a notebook. And the first chart that we're looking at here is basically a comparison of how many stops occur by race in Philadelphia. Certainly most stops happen to Black people. And then if we look at it as a proportion across time, we see that the amount of stops that happen to Black people is in the blue line here above. And there is this marked increase for stops that occur to Black people between, I would say, February to April, or maybe even May of 2017. And that increase isn't really represented in the other race breakouts. So that becomes kind of an interesting point of analysis. So I'm exporting all of the data for just March. And at this point, then you can bring it to ArcGIS. Let's go back to our data. And what we would have here is basically the ability to run a tool like collocation analysis. Let me just bring that back and forth here. So collocation analysis, the way it works is that it does this statistical check for whether two types of events are collocated. And the output is basically this assessment that if things are significantly collocated, they are symbolized as brown, meaning that stop and frisk tended to occur in the vicinity, both in space and time, of crime. So these are essentially more justified stop and frisk incidents, right? The police is responding to crime, or to some degree they're saying that that's the justification for that stop and frisk activity. But if you look at the isolated incidents, the green ones, especially the dark green ones that have statistical significance, these are the stop and frisk incidents where crime didn't really occur in the vicinity, both in space and time. So these are less justified type of activity by the police department. And it's not to place blame on any particular organization or person or even district, but it's really just to help activists and police departments both assess how to do things better moving forward, how to improve how we behave towards each other. And something like that could be used, for instance, in an assessment of per district, which districts are performing better. So here's the districts, and you may take the collocated or the isolated incidents and summarize within each district how many do you have that are not really justified by the crime patterns. And then we give you a map like this, where you would have essentially a count of isolated incidents, district by district, and then you could go back to your notebook and automate the production of those maps district by district so that you could report to your supervisor or to your activist organization about what's happening in Philadelphia. That's the end of my demonstration. Back to you, Shannon.
Thanks, Alberto. All right. Let's show my screen here. Now, you guys are seeing my notebook. Excellent. So I'm going to be in Notebooks and Pro here, and now we're going to take a little look at deep learning for automating the generation of some data here. Now, within the ArcGIS API for Python, we include 15 deep learning models ready to use. And this we add to and update almost every release. So you have things like Point CNN, which is great for working with point clouds. You have Mask RCNN, which I'm going to use right now for some object detection here. But basically, here I am in Jamaica Bay, New York. And what I want to do is automate a workflow that can tell me how many boats are in the water of the bay. So if you imagine maybe I do not know the role of somebody who needs to know this, but let's say I manage this marina area and I need to be able to have a count, like how many boats. Sure, I could like call people, I could talk to people, I could hope that every boat has some sort of IoT sensor on it, but maybe there's a better way where I can just get updated imagery and be able to get a count of these boats. So the Python API makes it really simple. So what I did was I created training data. And if you're wondering how much training data is a good amount of samples where basically I went and I manually said, this is a boat, and I outlined the feature and did all of that. It's about 1,000. 1,000's a good number. And you may say, I don't want to do 1,000, but doing 1,000 is a lot better than doing 1,000,000. So that's where the model comes in. So I'm just going to pick one of those models. For this problem, I'm going to use Mask RCNN. I'm going to point it at that training data. I'm going to use the built-in learning rate finder in the Python API to identify an optimal learning rate. And this is really great because when it comes to model training, you want to have a learning rate that's just right. You don't want it, you don't want to produce unstable training, and you don't want failure to train either. And this will help you get that. So we're going to plug that data in as we fit the model. So we're letting it train over time. So we can see how this is going. We just did it for 15 epochs. The selection of how many epochs is really, there's no magic number. So if you feel like as you're looking at these results, so what we see is the ground truth on the left. So that's data that I labeled. And then the model's prediction on the right, which is what the model actually came up with. And what we're looking for at this stage is more or less some identical images. So here we can see the model actually found 2 boats that are sitting on land, not ideal. Perhaps if we trained a little more, it would clean it up. But overall, as we're going through, it's looking pretty good. You can see it got 1 boat here. Hard to tell from this little chip if that is actually some land or a boat. But all in all, it's good. I mean, we're pretty satisfied with this. It's going to get us in the ballpark reasonably well. So let's take a look at the results. And here we can see what the model actually came up with. So now, as people are coming and going in the marina, I have new imagery available. All I need to do is pass the new imagery to my model, rerun it, and then I can have updated features, or I could do some analysis on that. And that's kind of what we would expect with object detection or deep learning. But there's also the ability to go subsurface with other data sets. So in 2012, Superstorm Sandy hit this area of Jamaica Bay, New York. And what it did was it caused a lot of the boats there to sink, and it caused a lot of debris to enter the Bay Area. And that's a problem because as people are trying to get back with their lives and start to recover, we need to be able to have resources come through here. We also need to clean this up from environmental purposes. We don't want to just leave all these boats sitting there. So using that same Mask RCNN workflow, we can actually detect the large marine debris. In this case, we were trying to identify potentially sunken boats from this data. And so we can see kind of what that looks like. And then where even more automation comes in, because this was just, let's get some raw data here, is we can actually use this to update nautical charts. So we already knew what the symbology for marine debris is, and now we could translate that into the correct symbology. So as groups are coming in and needing to clean this up, they know places where to avoid, where to prioritize efforts, and that can be really helpful. Now, one more thing I want to touch on as we are going through this is scheduling, because everything that Alberto and I showed you can also be scheduled. So here I have a little simple notebook doing some cluster analysis, and I want to schedule it. So all I need to do to create a schedule is go in and I can create a task. I'm going to enter a name. And then I'll touch upon parameters here in just a second, but let's just say we wanted to run it there. Maybe I want to run this once a month. If we pretended that this wasn't just clusters, but this was our boat analysis, maybe we have to generate a monthly report of, some boats or something. Whatever the scenario is, we can decide what day we might want to start on, and we can decide if we want this to run in perpetuity, if we want it to be end on a certain date, or if we want it to run for a certain amount of time. So we can just say, we're going to let this run 10 times. And I can choose to update the notebook with my results of this each run. Oops, sorry, let me put my day. There we go. And now I have a task scheduled. But here we can see some tasks that I created yesterday. You can see in this one, I had one that failed, and that was because my notebook actually wasn't structured to run in an automated fashion. When you're scheduling, you need your notebooks to be able to run without human input. And what I had done in this workflow, if we look at just some JSON, whenever it fails, you just kind of get JSON. But here it's going to tell me, where am I looking at? It's right here. What I had left was an output name. So I was rewriting an output that already existed. So that's what happened there. But the successful notebook, it actually gives us a nice preview. It gives me a bunch of Jupyter warnings because I ran in our dev environment, but we can see that the output that we wanted was created. And then if you wanted to parameterize a notebook, what you want to do is definitely structure your notebook for that. Another thing that you're going to need to do is turn on cell tags, which if you're not familiar with how to find that, you just go to View, Toolbar, Tags, and then you want to enter a tag wherever your parameters are and call it parameters, exactly like that, lowercase, word parameters, and there you go. And what this is going to allow you to do is actually define the space where you're going to input your changes. So here we can see some details of the tasks that I had created yesterday. So I defined the cluster size and the output. I just entered the values. You notice I didn't have to put quotes around it because it was smart enough to do that. And we can see the results. So it created new items for me because that's what I wanted it to do. And if I open this in the map viewer, get this out of here, you can see those results are ready to go. So if I needed to run this every day, if someone wanted to give me a scenario test where they say, okay, this time let's look at, clusters of 20 restaurants, because these are restaurants in Pittsburgh. That's all possible. You can do that with ArcGIS Notebooks. Now, really quickly, let's jump back to the slides. That was our last demo, so we hope you enjoyed that. Whenever we're putting this to work, we're really doing it for the purpose of doing something. And the types of applied analytics we'll see this coming into is either descriptive, predictive, or prescriptive. I'm not going to spend too much time on this because we're mostly out of time, but descriptive analysis is really answering what has happened. So even things like object detection could fall into that category. Predictive analysis is what could happen. This is where we see things like if we took Alberto's data cleaning voter turnout example to the next level, we might do a prediction of what voter turnout might be. This is also where we get things like regression and we're asking questions. And then what a lot of organizations at least aspire to is prescriptive analysis. What should we do? And kind of the key here is about constraints, right? We're going to have certain constraints come in. Sure, if we had enough time and money, we could make anything happen. But the reality of life is that we don't. So how do we make decisions and help aid decision makers to be able to make the right decision at the right time? And that's where prescriptive analysis comes in. And all of these types of workflows you can do in a notebook and you can execute that way. So just really quick, a conclusion here. Remember that notebooks, ArcGIS Notebooks, which Alberto and I showed you today, are available in the cloud, in ArcGIS Online, on your workstation, which Alberto and I both showed you in Pro, and for your enterprise. And they have the Python libraries plus those 300 open source packages. Notebooks are great for automation because they allow us to do analysis and document our workflow simultaneously. All that markdown that Alberto included makes that notebook way more accessible, especially for someone getting started. instead of just, here's a wall of code, good luck. And also, we can automate a wide range of workflows, whether it's a deep learning workflow, whether it is some data cleanup or just some analysis. And then those workflows can even be scheduled for an even greater level of automation. And scheduling isn't unique to notebooks. You can also schedule regular GP tools in ArcGIS Pro, but those are some options. And if you wanted to learn more, here are some resources. Sorry, Lipka, I'm stealing your resource slide, but there are some resources. But I will turn it over to you to get to the poll.
Perfect. And this is one of the last few polls we're going to have for the day, going back to Shannon's slide on the differences between descriptive, predictive, and prescriptive analysis. We'd like to understand a little bit more in terms of the types of tools you are looking for, given the types of analysis you typically do. So we'll put the question up here for a couple of seconds for you guys to select. This will really help our product teams to better understand in terms of what we should be working on next. So we'll give it a couple more seconds here for you guys to select. And great, this is fantastic information for us. And then we can go into our final poll, which is going to come up here in just a second. And this is just really to help us better understand if any of you would be interested in speaking with an Esri expert on how you might be able to leverage this technology within your organization. So if you saw something presented here today that really resonated with you, or if you have any questions that you'd like to have answered via a one-on-one call or an email, our team would be happy to discuss further. And if you're not ready for a conversation quite yet, but you're still interested in continuing to learn, the resources slide that Shannon showed up on the screen a couple of minutes ago will be shared with you as well via email. So don't be alarmed that we just had it up there for a couple of seconds. We'll keep the slide open for you as well to take note of. And I know we're at the end, so thank you again for your time today, and we hope that you were able to learn something new from the session and will continue to join us for future webinars and events. And with that, I'd like to pass it back to the Directions Magazine team to close us off.
Thanks, everybody. And just be aware that the team here at Esri will be diligently looking at your questions that you've submitted and following up with you personally. So remember that we will be in your inbox with a version of the recording, as well as all these great resources and links that you saw today. You'll have an attendance certificate available, and we appreciate your input on the survey on the way out. Thanks again, Shannon, Alberto, and Lipika.
Thank you. One quick thing for everyone who asked questions. I know I'm speaking for Alberto too, but we are super bummed we did not get to answer your questions, but we hope you enjoyed the demos we showed. But what we will do is Alberto and I will take as many questions as we possibly can and answer them in a blog, and we will, depending on when we get the list of questions, we'll put that out hopefully in time so that you can get a link to that with your email. But if not, just look for that from us, and we will be answering those. But thank you all so much for joining us.
Yep, thank you, everyone.
Thanks so much. Everybody go have a great day. Tell a friend about Esri and Directions Magazine. We'll see you soon.